So I'm Nancy Kaser. I've been sending all the emails I do, all the behind the scenes of Midway Physics Day this year. For those of you who've joined in the past, Sam Beals used to be in this role. He's actually moved to a different department now, so I'm taking over for that.
So Nancy is the new Sam, and I am the new Jeff. So Jeff is happily vacationing somewhere because he's retired. So I'm taking over now. So you'll be dealing with me. And I am the newcomer to this training day. So I will provide all the information, but I'm sure someone like Maria will be able to help a lot more, and she's going to educate me as well. So let's start and get this going, and then get everybody done and then relax a little bit because it is a school night. So the Midway Physics Day for this year is going to start. It's going to start, well, the training is only one day, and it's going to be on October 17th. It's a Tuesday, so it's going to be around 2 weeks from now. I am not able to now move on for some reason. Oh, there we. It's just slow. Okay, so this is the outline for the training. We're going to give a very brief description of the Midway Physics Day, and we're going to talk about some of the practical consideration, preparing for a lesson plan, and then how to execute the Midway Physics Day successfully, and discussion and with Q&A. So this is the updated map for the Midway Physics Day. We are at the academic avenue stage this year. So it's actually not, the location hasn't really changed much. It's in the same general area. It's kind of by the animal. So you guys are going to enter in by this main gate and then just head straight towards our tent. Once you get there, I don't know why it's. So the Midway Physics Day is going to involve a lot of physics demonstration. We have graduate student, undergraduate student, and actually professors there from University of South Carolina serving as mentors. And we'll have different demonstration stations, including optics, rotational motion, linear motions, electromagnetism, and the students are welcome to go through each station to learn about the physics behind each of the demo. And here's just some of the more updated picture from recent event. I think previously the training includes picture from probably from 1996. So these are just some of the more updated ones. So you're going to be working with college student, graduate student, and professors. And here's a brief timeline of the USC Midway Physics Day agenda. So from 9 to 11 a.m., that's us. We're going to be preparing for the event. We're going to set up all the demo stations and make sure the graduate student and undergraduate student and all the professors and the mentors involved know exactly what they need to do and need to talk about. And between 11 to 12 p.m., this is where the demonstration is going to happen. And this is where you guys are going to arrive. I believe the gate is going to be opened at 11 a.m. So this is when you guys will come in and then check out our demos. And so it's very important that you check in with us so that we know you're here. And so if you need extra wristband, or you have extra wristband then you can return it to us. But if you need extra wristband, definitely come talk to me and come talk to Nancy, and we can provide them for you. And so this is where you go around, check out all the hands-on demonstration. And from 12 to 2 p.m., that's when the rides are going to open. And this is the time where the kids can go on rides and then make measurements. We will have our mentor at the different rides, like specific rides, such as the, I forgot the name of the one where you go a straight drop. What is that called?
Drop a fear.
Yeah, drop a fear. Or the Starship rides. So in case you need help with the app or with how to make measurement, then you can actually talk to our mentors. So for you, what's important is you need to plan your activity ahead of time. Make sure you have a bus ride to and from the fair, so you have a way of getting there. And plan the lunchtime meeting, know when to do analysis, and then do group coordination. There's going to be a lot of distraction in the fair, so make sure you know where all the kids are and all the students are. And definitely plan some free times for the student so that they also get a chance to have some fun after they finish all their measurement. So here are the different demonstration stations that's going to be at the fair. And these stations going to run from 11 to noon. So, make sure you plan some activity relating to the demonstrations. So for example, have a requirement of how many demo the student must participate in and must be able to explain. So these demos is going to involve rotational motions, such as the rotational platform, and then vibrational spring that has to do with oscillations and measuring periods of oscillations. So singing bar is just another way of these oscillations, but in a very unexpected form. Bouncing ball is for momentum transfer, jumping ring, eddy currents, and these are for electromagnetism. Polaroid sheets, it's for optics. And then we also have a separate optics station demo that is run by a local optics company, Thor Labs. They were there last year and they brought in lasers so that they can see how mirrors and lenses work and how image can be created. And I will also have a separate demos, likely have a separate demo relating to how sugar water can rotate polarizations of light. And then of course, everybody's favorite, the liquid nitrogen demo station, so that's a little bit of thermodynamics. So have your student participate in a demo. And so in the beginning, so while you check in and use our academic avenue stage as the home base. So even after I think we have do we have the tent until 2 p.m.? Yeah, so you can still use that location as the home base, even though the demos will be gone by then. So preparing a lessons. So once you are done with the demo part, so the kids are now, they have to do their measurement on several rides. So so make sure you, before you go, make sure you choose a few rides to analyze. So only 2 or 3 is enough. If you do too many, then they can get overwhelmed because there's a lot of distraction at the fair. Don't overreach. Make sure you plan a lesson in line with the course objective. So like what you're teaching and what they already know. So keep it simple. Prepare with your student ahead of time before you arrive. So have a practice session in the class. So my recommendation is to actually have a pre-fair and a post-fair class session, but only if that does not interfere with your regular instruction. So make sure the pre-fair class instruction is to make sure, I think that's the more important one, because during that session, you make sure the student can do everything beforehand. So for example, if they have to bring calculator, pencil, printout, clipboard, and protractor, so all of these tools, you need to make sure they know how to use it. So for example, if they have to use a protractor in some other way to measure the height of a certain structure, then they need to know exactly how to do that beforehand. And we are going to recommend a lot of the measurement to be done with this app that is free on to be downloaded on the phone. So for example, the Arduino Science Journal app. So if you're using an app like that, make sure that this is downloaded beforehand and the student has a class session period to be familiar with all the measurement that is done using the app. So they know how to use it, how to collect data, and how to store the data to be analyzed later on. And then during the fair, budget the time so that the students are not stressed out, so that they can do everything successfully. So make sure you arrive early and prepare, and then during the bus ride, you can give further instruction and preparation, and then use the lunch period to regroup, and then make sure everybody at least collected all the data they needed. So that even though they don't need to analyze it right there during the fair, they can analyze it in a post-fair class session or at home on their own, and then then they can be presented during a class period, for example. So these are some of the rides that you can do measurement on. So the first one is the Ferris wheel. So for that one, some of the measurement that you can do is measure the height of the ride with a protractor or using air pressure. So the air pressure part is you have to have the app to do that. So I'm going to introduce the app in a bit. Or you can measure the period and frequency of the rotation for the Ferris wheel. And for the roller coaster, then you can use it to verify Newton's law and what are the forces involved on the rides. And then the drop of fear, there's the magnetic force braking. So this is to measure the free fall time, measure the height of the rides, and also use these two values to calculate the speed, for example, at the very bottom of the ride. Right? And then there's the Starship. Is it 2,000 or 3,000? I think it's 3,000 maybe. So this has to do with circular motion. So that they can definitely bring the app there to measure the acceleration once the ride is spun up, right? And also they can use it to measure the time period to get the acceleration, and then they can use it to compare to the measurement. So they will have to do a measurement outside the rides and then also have to do a measurement inside the ride. So these are known rides that you can plan ahead of time, ask them to practice what they need to measure so that once they're on the rides, they're not flustered and worry about measuring stuff, and also at the same time trying to enjoy the ride. I know I'm going a little fast. This is my first time doing it. I should probably take a break and ask, is there any questions so far? If not, and then you think of some later on, we do have a Q&A session. So we can do that then. So this is the app that we recommend. So this is an app for the smartphone that uses your smartphone's internal sensors to take a lot of the data. It's the Arduino Science Journal app, and you can download it for free. And I actually have downloaded the app already, and I had a test run, and it's actually really easy to use. Once you get the app going, you have a list of sensors that's associated with your phone that you can use, and you can pick and choose which one to use. So the bar up here shows you an array of internal sensor to choose from. And when in doubt, if you're trying to figure out what is this exactly measuring, so for example, this is accelerometer X. So it's measuring the direction, acceleration in the X direction. So you're gonna have like, well, which one is the X direction? If you click that little information button, it actually tells you what is the X direction with respect to the orientation of the phone. So you click on that, there's a lot of good information to tell you about the sensor itself and what exactly you're measuring. And then once you have this little icon up here is called Add Sensor. So what you can do is you can choose the sensor you want, push this button, then you're going to actually have another little tab opening over here so that you can actually measure two quantity at the same time. So, and then once you have all the sensors that you wanted to use, you can push record, and that will actually record the data that you collected during the time of the record, the record session, and it will save the numerical data to your phone. And if you push snapshot, that will only record the instantaneous value. So it's just one number. So I did a test run. So this is an example of recording my elevator rise from the 5th floor to the 1st floor in Joan. And I have 5 sensors selected from the phone. So the X, Y, and the Z, and linear acceleration, which is the total acceleration minus gravity. So if you look at these values closely, some of those value actually has pretty high value, 8.8, 7.8. It's because I have my phone kind of tilted. I'm just holding my phone normally on the elevator, so it actually has a Z and a Y component. And when you measure the acceleration as separate a component, it actually takes gravity into account. So if you were to put your phone flat like this is measuring acceleration in the Z direction. And if you don't move it, it actually measures around 9.8. So gravity is taken into account. However, if you only look at the linear acceleration part, then that is measuring the acceleration without taking gravity into account. So when you're using all of these sensors, it's very helpful. This is why the pre-fair session will be very important, because you get the student familiarized with all the capability of the sensor and let them know exactly what is being measured. So then once they're in the fair, they just need to know that, okay, I need to turn this on, turn this on, turn this on, get it going, take data, and make sure the data they have taken is valid. And so that they don't have to worry about freaking out. It's like, what am I actually doing? Like, what do I need to use to measure things? So the barometer is actually pretty impressive. I went from 5th floor to 1st floor, and then you can see the change in the air pressure. So this is the air pressure that can be used, and then later on using the equation to convert it into height, right? So it's good during the pre-session to the pre-fair session to let them do the calculation to see how close it is to actually to the actual height of an object. And then you can also use the pre-fair practice section to for them to practice using a protractor to estimate the height of an object, right? So once you have this all done, you press record, and this will all show up in the phone. And so the way to get to this is you press this arrow, so it goes back, and all of these will show up in the phone. And all you have to do is click one of those graphs, and then you're basically you enter in another window where there's going to be 3 dots on top of it, and you can use it to save to file. Once you do that, and you will have all of the information, the measure value, you can export it. It's going to be saved as a single Excel spreadsheet. So if your student already know how to do all of that ahead of time, then they can use all of this information later on, either at home to then analyze, to plot the data, and then and then they can analyze the result of their ride.
Young Win.
Yes.
Someone's asking if we use the app on the ride or as an observer.
On the ride. Yeah. So this is me taking the phone on the elevator with me. So I do recommend, you know, so it's good for them to know what exactly is the X direction, Z direction, and Y direction, so that they know exactly how to orient their phone when they're on the ride, right? So that, because these are actually measuring the acceleration in all of these three different directions. So if I remember correctly, the direction, if you lay your phone flat, then it's actually measuring the acceleration in this direction. And then if you move your phone sideways, or you lay your phone like along the long edge, then that's the X direction. And then, of course, if you lay it on like this, the short edge, then that's the Y direction. So it's good for them to play with that so they know exactly which direction is the correct direction. So then they know exactly how to orient their phone when they're on the ride. So for example, if they're on the Starship ride, they should, they probably try to hold it still like this. But then if they have all the measurement, the XYZ selected and the total, then they actually have all the necessary information for them to analyze their data later on. Right. So yeah, thanks for the question. I haven't been monitoring the chat. Is there anything else I need to answer?
Another question is someone's asking about a protractor app, but Maria's answering that for us.
Okay, thank you,
So
Maria.
thank you, Maria.
Awesome. And so I think in here, there's not a protractor app. I think there is a protractor app, but it's called a compass app. So it actually does measure angle. So I'm not sure if it's the same thing, but I know for sure that this app can also measure sound frequency. So it would be really helpful to use the same app. If you select the sensor for sound frequency, that would be very helpful when you are at the singing bar station, for example, where what they do is they actually rub a aluminum bar with a kind of like a very frictional cloth, and you can actually get it to, if the resonant is hit, you can actually get it to emit this really high pitched sound. So that would be a good station to use the sensor to measure the frequency of the sound wave. And there's also a sensor for measuring the intensity of light. So that would be a good sensor to use at the polarization station, where they can play, they can use two polarizer to change the intensity of the light passing through. So they can put their sensor on one end, and then as the polarization film is rotated with respect to each other, and then the light transmitted is reduced and increased, then they can use it to also see oscillations in the intensity. So that would all be a sensor that would be useful for the different station. There's also a sensor that measure magnetic field in the same app. So imagine you can use that sensor close at the electromagnetic station as well. Right? So it's important to get the student familiarized with all the different sensors, so that they know which one they can use at the various stations for the measurement. So then they can actually get some data on top of just observation. And I think the app will allow you to take note at the same time. Is there any other question I need to answer? Okay, cool. Okay. So everything that you're doing at the fair can actually help you to satisfy some of the SC educational standards. So for example, standard HP1, the student will use the science and engineering practice, including processes and skills of scientific inquiry to develop understanding of science content. So it's very important to ask your student questions that is not related to the formula. Just ask them about the concept and the physics behind it, and ask them to explain it to you without actually using any formula. So for example, ask them to think about where are they feeling the forces? once they're in the rides, right? So for example, some of the worksheets that we put on the website is going to ask these non formula related questions. So it's really just concept based. And then, so the HP2 and HP3 is more specific. One is to understand and predict using the interaction among objects, and the subsequent motion can be explained and predicted using concept of force. So all three of those can actually be done if you go on a roller coaster rides, because there's a lot of different forces changing as you go through the roller coaster. And if you ignore friction, then you can also satisfy standard HP3, which can also you can use the concept of conservation of energy to explain the roller coaster ride as well. So, definitely challenge your student to think about all of these questions before they go on the ride. So they have those questions in mind as they go on the ride, and then they can sort of match what they experience to those concepts. And so, for example, this is one of the example is the roller coaster activity. So some of the question that they should think about is, why is the second hill shorter than the first? So for example, what happens if the second hill is not shorter than the first? What's going to happen to the roller coaster? Of course, this is assuming there's no friction involved, right? So, and then you ask them, if the roller coaster is at the very top of the first hill, how much potential energy is stored? And then determine the gravitational potential energy on the second hill, right? What's involved? How do you determine that? What kind of value do you need to know before you can make that determination? Label the section on the sketch that represents the greatest kinetic energy, and also determine the average and maximum velocity of the ride. Where does the maximum and minimum acceleration occur? And so if they have this question in mind before they go on the ride, that they can actually pay attention to that. At which point do they actually feel like they're under the most force? And then compare the calculated acceleration with the acceleration that measured with an accelerometer. So this can be taken care of with the app from the phone. And so there's a lot of printed resources available, teacher's guide, sample worksheets. If you have never done a worksheet before, we actually have those available on our Midway Physics Day website, and along with the state standards. So if you don't know where to start, definitely go on the Midway Physics Day website. And I think by now you guys should all know where it is. And we just updated it. So you guys can look through it, download and use some of the worksheet that we have up there. If it's the first time you're doing this. Yes.
Do you mind if I go ahead and share that stuff?
Oh yeah, go.
Okay. Can you stop sharing your screen? Um, so if you, I'm sure some of y'all are familiar with our department website. So we have updated it. If you go to Beyond the Classroom and right there at Midway Physics Day. And if you scroll down here, we do have teacher resources available and activity sheets. So if you look at our activity sheets, they're actually worksheets that we've had. They have been updated. If in the chat, if you want to put, I am trying to work on a digital version so that students don't have to bring clipboards and paper. If that's something you guys are interested in, I can create either a Google or Microsoft form and give you guys access, and you can make copies and add it to. When I was a teacher, we were a Google district, so you can attach it to your Google Classroom or whatever you guys use. And I would honestly focus on one or two worksheets. I wouldn't try to do the whole packet. It's a lot. Um, so we have like the Ferris wheel, and I'm not going to redo the questions or the problems, but you have a couple of questions per different ride that they can go on. And we do offer like either a roller coaster one where they can ask extra questions, or we had a different rotational one. So that if they wanted to go on a ride that we didn't list, that's fine too. And then that they can just put down their ride name or whatever. And you guys are welcome to use these. These are available just to try to make it a little bit easier for you guys. And then if not, you guys can make your own. Nancy Smith, our contact at the South Carolina State Fair, is really adamant, and we are as well, about making this educational as well as fun. So just to try to help you guys out, we do have these worksheets available as well. I don't know if anybody has any questions.
And if I can share, it's pretty much the end, but let me see. So there it is.
And we also, I'm sorry, I just remembered, we
Go.
have under those teacher website, teacher resources, we have different formula sheets and things like, and talks about the rides and stuff like that that Jeff Wilson created for us a while ago. And I just updated a little bit to kind of work with where we are now. But like I said, if you guys want me to make a digital version or something, I can do that as well.
Yeah. So this brings us to the final thought. So the Midway Physics Day is a fun and effective way to motivate your class about science. So we would like to know what else can we do to help improve this experience, because we noticed a lot of the material were outdated, but we updated a lot of them. But if we can do something else to kind of bring it a little bit more towards the modern days, like using the phone app is definitely a huge plus, because now you don't have to bring these crazy accelerometers, and like everybody has a phone, so you don't have to bring like all of these tools up on a ride and then stress about reading it while you're in the ride, because once you start recording, then you can enjoy the ride, and then everything is already in the phone, and then after the ride's done, you just need to stop it, right? So all the data are there. So, but if you can think about any other way for us to improve this experience and make it easier, and also more informative to also help the student learn, please let us know, including whether if you want us to start a teacher resources hub where we can put our resources there, but then all the teacher can also share their successful lesson plan with everyone else, then that would also be great as well. So let us know. And with that, that's the end of the training. So thank you. We'll see you in 2 weeks. Be happy to open this up for Q&A. And I'll try my best to answer all the questions. So we're both new, so I think Maria is gonna have to
And Maria, I don't know if the chat's gonna save. If you don't mind, can you email me this information and if I can add it to that hub?
Wait, so you're telling me I gotta work for free some more? What kind of crap is this? All right, look, people, I'll be honest with you. Don't make the kids go in there with packets and pencils. They'll stab themselves. This is what they do. They stab themselves sitting in your room blinking at you. Like, they're gonna kill themselves at the fair. Don't do it. Also, remind them that eating hot dogs and drinking like purple juice or whatever, or blue juice, and then getting on Starship 3000, especially when I'm on there, just like is a bad idea. I don't enjoy your gastric juices. I like your outside, not your inside. Keep your insides in. Thanks, guys. No, I'm kidding. The kids are gross, but they're gonna hurt themselves. I used to make them make accelerometers out of like tubes and a whole bunch of other stuff. But when these apps came out, it was over. This was so much easier. I use VFox because it has a video, and I posted the video with the elevator ride with the barometer data. Their app also takes a derivative of the accelerometer data, so you get velocity, which is nice. And it'll show them how to do height. So he does talk about all that, like, and it's like a 4-minute video. So kids usually like that. We are every other day, so we only get to forces right now because I see the kids every other day. I don't see them every day. So that's why my stuff is all forces. So that's what you'll see. And sure, what is it? Is it Katie? Man, who's the new Sam? Katie, right? Is it Katie?
Nancy.
Nancy, my bad. There was like a K in it. Sorry. So you just remind me. I don't know. These are all just Canvas posts I'm trying to copy paste. They're just my assignments in Canvas. That's all this is. I've also learned not to do too much at the fair. So usually the day before the fair, we have a lesson and we do all the elevator math, where we like, what is your weight going up in the elevator? So accelerated frames, basically. And we do a whole bunch of math with it. If I had them every day, then I'd probably do some kinetic and potential energy and stuff. We're just not there yet. We haven't even done UCM yet. So, and then what they do is they analyze a jump. They all jump in class with VFox and they analyze a jump. And we calculate how heavy you are on the takeoff, how heavy you are in the air, and how heavy you are in the landing. And that's what they use to get their data as they ride rides. My thing is they only have to do 3 rides. I don't care which 3, but I need data. I need a picture of you in the ride. And when we come back, we write it up. And I think I shared in the chat, I shared an example, like there's some examples of their little posters that they create. Let's see what else. My APC Mech kids, usually I ask them to do Excel rotation. So I want to see some gyro data, and we'll talk about rotation and like it's that's baby statics and dynamics for those of you who teach the undergrads. So yeah, they got to know some little bit of torque, just a little bit. For the demos, I usually make them do 5. I don't care which 5 they do. They have to talk about it, they have to write about it, and they can record themselves. It can be talk to text. It just can't be garbage. And then they turn that in. Those who aren't going, they watch like a little video demo thing that I've made up just because we are required to have something for them to do if they're not going. I didn't know how to address that other than here's a video, watch video, answer questions on video, move on with life, kid. Everybody else who's not going, they have to do data of a spin in a chair. Let's see, a jump and a run. So a jump, a run, and a spin. So horizontal, rotational, and vertical. And that's it. And all we're doing is we're mostly looking at accelerometer data, accelerometer, barometer, and gyro for the AP kids. And that's about it. That's just because we haven't gotten to anything else. My AP Physics C electricity and magnetism kids they're looking at brakes. When do roller coasters and when do these rides use their brakes? Because if you can actually turn on, I think it's like magnetic fields, the magnetic field sensor will give you data for that. And it's like you can actually see the spikes when the brakes come on some of the rides and the roller coasters. So that's kind of cool. And then we talk about it because right now, again, with that group, we're only on let me see, like, where are we at? We went through Coulomb's law. Like, we're like just electrostatics. We're not even at full circuits yet. So, because again, I see them every day or every other day.
So for things like magnetic braking, that would be one of the demo kind of illustrates that.
Yeah.
So we can we'll make sure to train the mentor to also mention that some of the rides actually use that for.
Yep. Yeah,
So
that's it. But like I said, I use VFox. I like the Arduino app. It is easy to use. SparkView does the same thing. It's like Vernier's app,
yeah.
but I personally like VFox because they have video directions, and I mean, I can give them all the instructions I want, but they're ultimately going to ask me a million silly questions. They're going to be like, what do you mean? I didn't know what to do. You didn't explain it. It's like, I said this 15 times, man. Like, we all calculated our weight. What were you doing? Oh, oh, the wall looked good. Cool.
So so I think a lot of the information, I think you probably provided that last year as well. So
Yeah.
we are going to include that in our post training recap sheet that we're going to make available to everyone else as well. So, which is just a summary of the training in PDF form and all the useful links and information all in one PDF form. So, anyone else have any other questions for us? And if you suddenly think about something after the training, feel free to email me or Nancy, and then we'll be happy to answer any question you have. Especially after you have a chance to look at the worksheets, and if you have question in terms of how to construct the lessons plans from that point on, then I'll be happy to help out with that.
And please, please, please don't remember. I mean, please, please, please remember to check in on the 17th. Either I will be there or James will, or one of our staff members, James Clausen, he'll be there signing people in. He's a very, very tall man. You guys
Yeah, you
cannot
won't
miss
miss him.
him. Um, and I will, Leah, I just saw your chat. I will try my best to have a digital version ready before Physics Day, but please don't hold me to it if I don't. I'm My goal is to do it next week.
Yeah, but we'll definitely have a version for next year. So
Yes.
we're just trying to make it easier for all the teachers bringing their kids to the fair. Like Maria said, you don't want them to bring all of these weird things with like springs and pencils and protractors that can fly off during the rides, right? They're definitely not going to let their phone fly off during the ride. So you just need to make sure they hold on to their phone, maybe, and then like put them in a certain position so that they make sure that their measurement will be accurate. So like all of that you can talk to them about before coming. So they do some practice session in terms of how to orient their phone when they're doing the measurement. So any other questions? Okay. If not, then let's wrap this up. But like I said, if you have some questions and then you're like, oh, wow, I wish I had asked that, just send us an email and then we'll be
Yeah.
happy to answer your question before you guys show up at the fair. So that we'll see you guys in 2 weeks. And thank you for coming
And
to the training.
yes, thank y'all so much. And if you didn't write your name in the chat bar with your school, if you could go ahead and do that. That way I just know who all joined. I really appreciate it. But for everybody else, thank y'all. Have a great night. And